Hello and welcome back to Sheaff Math. In today's lesson, you are going to be learning how to solve quadratic equations using the quadratic formula. Now let's do a little review of what quadratic equations are. Now this is a generic form of the quadratic equation that we deal with quite a bit, and you've probably been solving these in certain ways. Now what a quadratic equation makes on a graph is a parabola. And when you're solving these quadratic equations, what you're doing is you're trying to locate the x-intercepts, okay? And 99% of the parabolas that you are going to be doing this year are going to have two x-intercepts. All right, now you might have learned a few methods to solve for x without the quadratic formula. The first one is graphing. You might have been asked to graph the parabola and then found out where those x-intercepts are. You might have done factoring, where the FOIL method type of factoring and solving for x, and those answers are the x-intercepts as well. You may have even done completing the square as well, which is a good method too. But the problem with these three methods is that most real quadratic equations aren't easy to solve like these. And so mathematicians came up with something, a formula, to solve every single quadratic equation. And this magic formula is called the quadratic formula. Okay? Now here is the quadratic formula, and if it's the first time you're seeing it, it's going to blow your mind with all the a's, b's, c's, and x, and squareds, and plus, minus, and all that stuff. But once you get used to it, it's really not that bad. But you are going to be able to solve every quadratic equation possible. So we're going to be using the quadratic formula for a few problems to give you an idea and explain just those instances where you wouldn't have been able to solve it without it. Now, the first thing that you have to do is you have to identify the a, b, and c of the equation. Now, this one is just the generic form. Usually there's, all the time there's numbers in there. And so the a is the number that is in front of x squared. It's the coefficient of x squared. So whatever number that is what a equals. Then b is the number that's in front of x, the coefficient of x. And c is the constant right there, adding or subtracting from the x. Okay? Now, this is a real quadratic equation. And so what we're going to do is we're going to first identify the a, b, and c, and then we're going to go through how the quadratic formula works. So I did something tricky here at the beginning. What happens if there's no number in front of x squared? Well, you should know by now that there's always a 1 in front of an x or x squared or y if there isn't another number there. We just assume that it's a 1, and so a equals 1 in this particular situation. B is the coefficient of x, and so that equals 4. And then c is that constant right there, which is 3. So we have the a, b, and c. Now it's time to do the formula. So what we're going to do is we're going to put our a, b, and c and the numbers that we found for them in for each of those a, b's, and c's that we have there. So I'm going to put them in, and I want you to see how it worked. So I color-coded it so you could see I put the 4 in for the b's, I put the 1 in for the a's, and I put the 3 in for the c. Okay? And once you do that, you are going to start simplifying. And so we're going to simplify under the radical first. And 4 squared is 16, and then minus 4 times 1 times 3 is 12. And then I also simplified the bottom, 2 times 1. So now we still have to simplify under the radical, and so we get, up on the top right there, a 4 underneath it. And so this is good news. 4 is a perfect square, so we're going to have two really nice answers here. So we're going to simplify that, and we get y equals -4 plus or minus 2 over 2. Now what does that plus or minus mean? Well, it means that you're going to have two answers. See, your two answers are going to be -4 plus 2 divided by 2 and -4 minus 2 divided by 2. And so you need to solve two equations. So we'll separate those. Now the first one, -4 plus 2, is -2 over 2, and that makes -1. And then the second one is -4 minus 2, which is -6 over 2, which makes -3. And these are the x-intercepts on your quadratic equation. Okay? You have solved this quadratic equation. All right, here's a new one. We first identify the a, b, and c. 2 is our a, -7 is b, and 3 is our c. Here is our quadratic formula. We are going to substitute all of the appropriate numbers in there. So I put -7 in for the b's, 2 in for the a's, and 3 in for the c. And now we're going to start simplifying. And I'm going through the simplifying kind of quick, hoping that you know how to do this already. So the first thing is that minus -7 turns to a +7, plus or minus the square root of 49, -7 squared. Now, that's important to put that -7 in parentheses because you are squaring the entire -7. You don't want to end up with a -49 there. It's going to be +49. And so 4 times 2 times 3 is 24. We need to keep simplifying, and we get 25, which is a perfect square, so we're going to get a good answer again. And we get x equals 7 plus or minus 5 divided by 4. We will separate the two equations. X equals 7 plus 5 divided by 4, and x equals 7 minus 5 divided by 4. So the first one, we get 12 over 4, which is 3. And then the second one is 7 minus 5, which is 2 over 4. And that comes out to a fraction, but that's okay. We don't mind fractions. You could put either 0.5 or 1/2. It just depends on what your teacher wants. And there are the two x-intercepts for our quadratic equation, for that parabola. All right. Here's the last one. We're going to locate the A, B, and C. So A is 4, B is 6, and C is 1. See, that's really easy to identify, isn't it? So we'll use our quadratic formula. We'll put the correct numbers in their correct places. I use 6 for the B's, 4 for the A's, and 1 for the C. And now it's time to simplify. And so underneath the square root, I get 36 minus 16. So I need to keep going. And we get -6 plus or minus the square root of 20 divided by 8. Now, the square root of 20 is not a perfect square. So we're going to stop for a second. And what we're going to do now is we're going to separate the equations at this point. There's nothing more you could do by hand to do this, to simplify it. So we're going to separate them into -6 plus square root 20 divided by 8 and -6 minus square root 20 divided by 8. Now, at this point, you're going to need a calculator. And hopefully you have a good calculator that can solve this for you pretty easily. And so I used a calculator and got the answers. And so the first one equals -0.19, and the second one is -1.31. And the answer depends on what your teacher's asking or the assignment is asking. It might have you round to the nearest tenth or hundredth. In this case, I rounded to the nearest hundredth, the second decimal place. And those 2 points are the x-intercepts on your parabola. Now, there's 3 special items I want you to know before we go here when you're dealing with the quadratic formula. The first thing, if you end up with one answer instead of 2 answers, and it could happen, then that means the parabola is actually starting on the x-axis. Let me show you. So we have our graph here, and our parabola, if you notice, it starts at the x-intercept. And so it only has one place where it crosses the x-axis. And so this happens when your radical turns to 0. And you may be dealing with that or not. So that's what happens when you end up with one answer. Now, suppose you end up with a negative number under the square root. It means that there are no real numbers, no real answers, okay? Now, this is a higher level math concept, and so I'm not going to try to explain it too well, but visually, what it looks like is if you had a parabola that never did cross the x-axis. And so at this point, you're not probably going to do these problems, but if you did get a negative under the square root, there would be no way for you to solve that. It wouldn't be a real answer. So that's what that looks like. And then number 3, don't get fooled by an equation that looks like this. And this happens all the time. Students look at this and they want to immediately find the a, b, and c, but there's a problem. The c is not in its proper place, is it? We have to have 0 on the right. So we need to subtract 12 on both sides, giving us 2x squared minus 3x minus 12 equals 0. Okay. And there you have it. Boy, that was a lot for you. If it's the first time you've seen this, I encourage you to go back and watch it again and really get some practice on it. Thank you for watching, and we'll see you next time.